In today's lecture, we are going to study distillation operation. So, what is distillation? What is distillation? So, this distillation is a operation. Distillation is an operation in which for separation of liquid homogeneous by partial vaporization and condensation. So, distillation is an operation in which separation of liquid takes place by partial vaporization and condensation. So, for example, homogeneous mixture means what? Homogeneous mixture. Homogeneous mixture means in which two or more than two components are completely mixed. We can't separate this component. For example, wine. Because we know that in wine, alcohol, that is which alcohol? Ethanol and water is mixed. So wine is nothing but homogeneous mixture of alcohol, that is ethanol and water. So in wine we cannot separate ethanol and water. So when you want to separate the ethanol and water in the wine, we have to go for partial vaporization and condensation operation. So these two operations takes place in a one operation, that is called distillation. Now go to the second point. Distillation with rectification gives almost pure component. That means when you go for repetitive distillation, then you get almost pure product, that you can separate here ethanol and water from the wine. From the wine, you can separate ethanol and water with the help of which operation? With the help of this distillation operation. Go to the third point. The product removed from the top is called distillate. So when distillation operation takes place, the product which is get from the top of the distillation column is called distillate, and distillate contain more volatile component. Now come to the fourth point. The product removed from the bottom is called waste. The product removed from bottom is called waste. So whatever product you get from the bottom of distillation column is called waste. Now you please observe this material balance, and with this you will get the percentage recovery and other information. Okay. So here we have this block diagram of distillation column. We have this particular block diagram of distillation column. Okay. And here there are two components, A and B. So just for explanation, we are considering there are two components, A component and B component. The component A is more volatile component. The component A is more volatile component. Now more volatile means what? More volatile means that easily gets vaporized. While this component B is less volatile component. The component B is less volatile component. That means its boiling point is more. While more volatile component, its boiling point is less. For example, again I take example of ethanol and water. Ethanol E, water W. So ethanol boiling point is less than water, therefore we say ethanol is more volatile component. Ethanol boiling point less than that of the water. So ethanol is more volatile component, while second remaining component will be less volatile component. Okay, and these two components present in the feed. Okay, so this feed contain component A and B, and our aim is to separate this component this homogeneous liquid mixture component. For that we go for the operation that is distillation. Okay, and what is happening in the distillation? In distillation, this feed is heated and then it is cooled. Okay, so when this feed is heat-gated, this vapors goes to the top of the column. This vapor goes to the top of the column, while liquid go to the reboiler of the column. Okay, so this vapor go to the condenser. Vapor go to the condenser where these vapors are cooled and you get distillate. Okay, this vapor goes to condenser where these vapors are cooled, and this vapors cooled is called distillate. This is called distillate. While this liquid is given to the reboiler. Liquid is given to the reboiler, and this remaining component here after reboiler, that is called waste. Okay, that is called waste. So the liquid, I think whatever you are getting from bottom of this distillation column, that is waste, and whatever you are getting top of this distillation column is called distillate. In short, in distillation here we have only one input, and this input is nothing but feed. While there are two outlets, one is distillate, second is waste. Okay, so in distillation we have one input stream and two output stream. So based upon this, now we will go for the material balance equation. Okay, so our total material balance equation, we have only one input stream, that is feed, and we have two output stream, that is distillate and waste. And therefore our first material balance equation, feed is equal to distillate plus waste. Okay, so this is our total material balance. It is also called TMB. Okay, this is called total material balance, that is feed is equal to distillate plus waste. Feed is equal to distillate plus waste. Okay, so this is our total material balance equation. Now in distillation what happens? In distillation there is heating and cooling. Okay, so the component A will be remain A only. The component A will be remain A only, B will be remain only B. There is not reaction, there is no reaction, only heating and cooling operation is there. And therefore whatever A in the feed, whatever component A in the feed, you will get that amount of component in distillate. So A in distillate and A in waste. So whatever A in the feed, you will get same amount of A in distillate plus waste. So suppose 10 kg of A in the feed, in distillate plus in waste, the total amount of A must be 10 only. Okay, so now we go to the second important equation, that is called material balance of component A. As there is no reaction, whatever A in feed, you must get A in distillate plus A in waste. Suppose there are 10 kg. Suppose there are 10 kg of A is coming. Suppose there are 10 kg of A in the feed. Then suppose in distillate you get 2. Suppose in distillate you get 2. Then the remaining 8 must be in the waste. Then remaining 8 must be in waste. Suppose in distillate you get 4. Then remaining 6 must be in waste. The total must be equal to A in feed. So how you now calculate A in feed? So A in feed calculated by this equation, F into XAF, where where F is the amount of total feed and XAF is nothing but what? Fraction of A in feed. So fraction of A in feed means what is the amount of A out of 1? Fraction means out of 1. Okay. So this is equal to D into XAD, where D is the amount of distillate and XAD means fraction of A in distillate, plus W into XAW, where W is amount of waste and XAW means fraction of A in waste. When you are going to solve this problem, at that time you will get clear meaning of this particular terms. So we are going to solve this one problem related to this. Okay, so with the help of these two equations, different equations, you can solve two unknowns in this particular distillation operation. So we have two equations, that means you can find out two unknowns in this distillation operation. Okay, so just I repeat this part. So distillation operation used for separation of liquid homogeneous mixture. And in this distillation, which operation takes place? Partial vaporization and condensation. So best example here, the wine is the homogeneous mixture in which ethanol and water is present. Second point, so repetitive, if you go for distillation, you can get 100% product A and 100% product B. That means almost pure product you can get with the help of distillation operation. So whatever product you get from the top of this distillation column is called distillate, and the product which is get from the bottom of the column is called waste. Okay, then we have studied this particular block diagram. In distillation there is only one input, and there are two output. One is distillate, second one is the waste. Okay, and therefore we get first material balance equation, that feed is equal to distillate plus waste. So this is our first material balance equation, which is called total material balance. Then we have studied this material balance of component A. And what is that component? So whatever A component in feed, that must equal to A present in distillate plus A present in waste. And these amounts of A in feed is given by F into XAF. A in distillate is given by D into XAD. And A in waste is given by this equation W into XAW, where X nothing but fraction. So XAW means fraction of A in waste. Okay, now we'll solve one problem related to that, and from that you can find out some unsolved problem. So with the reference of this, you can solve unsolved problems.